Okay, this is part 2 of the study guide. Again, you can just fast forward to the questions that you are stuck on. So let's take a look at 26. Find the measure of each indicated side. So we're going to round to the nearest tenth. So again, still stand at the angle. This would be opposite. This would be adjacent. So we still have tan, but we write 32 degrees next to it. Would be opposite, which is 12 over x. So putting this over 1 and doing some cross multiplication, I'd get x times the tan of 32 equals 12. And then I just divide by tan of 32, because you can't take that angle away from tan. And then you let your calculator do all that work. So 12 divided by the tan of 32. Again, make sure your calculator's in degrees. 19.2. Same thing here. You're going to stand at the angle. This is opposite. This is hypotenuse. Well, that's sine. Sine of 67 degrees is x over 5. Multiply by 5 sine 67. And put that in your calculator, and you should get 4.6 for x. So the side length is 4.6. Number 28, find the exact values of the 5 trigonometric ratios that are not given. So a couple things they're telling you here. If sine is less than 0, then sine is negative. And remember, we're talking about quadrants. Quadrants, sine is negative. All students take calculus. Sine is positive in here and positive here, but sine is negative here and here, in quadrant 3 and quadrant 4. Cotangent, which is the reciprocal to tan, is also negative. Well, cotangent would be positive in here, so it's got to be in this quadrant. So I'm going to draw it. I'll put my theta right here. And cotangent is the reciprocal, again, of tan. So tan is opposite over adjacent. This would be adjacent over opposite. So the adjacent side would be 4. The opposite side would be negative 3, because I'm going down. And then using Pythagorean theorem, this would be 5. So now I'm going to write all of my other trig functions. So sine is opposite over hypotenuse, negative 3 over 5. Cosine is adjacent over hypotenuse, 4/5. Tangent is negative 3 over 4, opposite over adjacent. And then you just flip them. Cosecant, which would be negative 5 over 3. Secant, which would be 5 over 4, and then obviously cotangent, which they gave to us, which would be negative 4 over 3. All right, getting to this one, you really do need to have your unit circle. We use the paper plate, but you need to have a unit circle written down on a note card. So the inverse sine of 1, that's the angle that will give you a sine of 1. So we're looking for sine, which is the y-coordinate, to be a 1. It's 1 right there. That's the only time it's 1. So it's at pi over 2. How about this one? What is the inverse cosine of negative root 2 over 2? So again, I'm looking for the cosine, which is the x, to be negative root 2 over 2. There's 1. But it's also negative root 2 over 2 down here. Well, cosine, inverse cosine can only be in these two quadrants. So we're going to choose the 135 degree, or the 3 pi over 4. Tan of negative root 3 over 3, again, kind of looking at the back, tan of positive root 3 over 3 is a pi over 6. It's all the 30 degrees, but I want it to be negative. So tangent is negative in these two quadrants. So I'm looking for the 30 degrees in these two quadrants, which would be here and here. Now, which one do I pick? Well, tan can only be, the inverse tan can only be in quadrant 4 and quadrant 1, so we're going to pick 11 pi over 6. You could use your calculator for these, and they'll give you the right answers, and your calculator's in degree mode. So you could do something like second inverse tan of negative root 3 over 3. But with your calculator, whoops, being in degree mode, it really won't work as well for you. Oh, it does. My bad. I lied. Negative 30, which is 11 pi over 6. So you could use this also to your advantage. Okay. Find the amplitude period in radians, phase shift in radians, and vertical shift. You do need to remember and recall that the number in front of sine is your amplitude. That next to the sign in a parenthesis, usually you have a bx plus a c, or sometimes the x is theta. But the number in front of theta, that b, helps you find your period, but you have to divide it by 2 pi. The c will help you find your phase shift, but you set that equal to 0. And then the d on the outside is your vertical shift. So when I'm looking at this, the number in front is my amplitude. Amplitude is 8. Over here, amplitude is 7. The number in front of theta helps you find pi. You just divide it by 2, helps you find, your pi, the period. You just divide it by 2 pi. The number in front of this is 1/4. And 2 pi divided by 1/4 is actually 8 pi. Same thing over here. The number in front of theta helps us find the period. You just divide 2 pi by 4, and that would be pi over 2. To find the phase shift, we set this equal to 0. So 1/4 theta minus pi over 6 equals 0. 1/4 theta equals pi over 6. Multiply by 4, and you'll get theta to be 4 pi over 6, which is 2 pi over 3. So your phase shift is 2 pi over 3. Let's do that again here. You're going to set this whole thing equal to 0. You're going to get 4 pi equals 2 pi, negative 2 pi divided by 3, and you're going to divide that by 4. And again, you can let your calculator do that work if you're unsure. Alpha y equals is a fraction button, so negative 2 divided by 3. Don't worry about the pi. And then divide that by 4. And you'll get negative 1/6, and you just put a pi next to it. So phase shift is negative pi over 6. And then there is no vertical shift because there's nothing on the outside. All right, solving some trig equations. A lot of students don't like these. Your job is to get the tan of theta or the cosine of theta or whatever you see by itself. So I'm going to get tan of theta by itself. I'm going to divide out that 1/2. And you're going to get tan of theta to equal 1. And then you're going to go to your unit circle. And where is tan equal to 1? Again, I look at this side. Tan is equal to 1 at 45 degrees. So I'm going to go to all the times that tan has a 45. There's a 45 right here. 45 degrees right there, pi over 4. And then right here, 5 pi over 4. That would be positive also. Pi over 4 and 5 pi over 4. Let's do that again for this one. Get cosine theta by itself, so I'm going to divide 8. This right here would reduce down. 4 goes into 8 2 times, so it would be negative root 3 over 2 equals cosine theta. Let's go to our lovely thing. Where is negative root 3 over 2? Right there. Is there another negative root 3 over 2 for cosine? Yes, there is, right here at 5 pi over 6 and 7 pi over 6. right. Negative tan theta. I see another tan. I might just get all my tans on one side, so I'm going to add 2 tan theta. And that would give me 1 tan theta, which is what I want, equaling negative root 3 over 3. So again, looking at the back, positive root 3 over 3 is the 30 degrees. And tan is positive here and here, these two. So I want to just go here and here for negative root 3 over 3. So it's at 5 pi over 6 and 11 pi over 6. Same idea, minus the 3 tan. You would just get 1 tan and you get positive root 3 over 3. We just talked about that. That would be these two right here. So this would be pi over 6 and 7 pi over 6. All right. For these two questions, we're testing you on the law of sines and the law of cosines. How do you know when to use which one? If you know an angle for a triangle, notice the triangle's not right, you know the angle and its opposite side, you can do the law of cosines. Excuse me, a law of sines. Angle and its opposite side would be the law of sines. And the law of sines says the sine of an angle, 33, over its opposite side is equal to, since we're finding angle A, we're just going to write sine of angle A over its opposite side. And we're going to crisscross. So we get 35 sine A equals 23 sine 33. We got to divide out the 35. Let your calculator do this part. So 23 sine of 33, I would hit enter, and then I would divide that whole thing by 35. You're going to take that, now look what we have left. We have the sine of A equals that weird decimal, 0.3579. So how do I ever find angle A? I would inverse this, inverse sine of that right there. And I'd get 20.97, or A is about 21 degrees. Well, it said round to the nearest tenth, so 21.0. So that's the law of sines. The next page is telling you to do it the law of cosines. And it says solve the triangle. Honestly, on the test, you're just going to have to find the one angle. So I'm going to switch the directions to this one. I just want you to find angle A. Since it's a side, 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 you're going to do the law of cosines. So A squared equals B squared plus C squared minus 2BC cosine of angle A. Write that down. Make sure you know that. Give yourself an example. Opposite angle A is little a, opposite angle B is little b, and little c. And you put those in the formula. So 16 squared equals 26 squared plus 14 squared minus 2 times 26 times 14 times the cosine of angle A. And really, most of this is calculator, so we're just going to find out what 16 squared is. 256. And 26 squared is 872. Well, I should say 26 squared plus 14 squared is 872. And then 2 times 26 times 14 is 728 cosine A. You've got to subtract this over first before you can't combine these two together. This has a cosine attached. So you need to do 256 minus 872. Negative 616 equals negative 728 cosine A. Now you can divide negative 728. You get 0.846. And again, to find an angle, you inverse cosine that. 32.2 degrees. All right, number 40, find the exact value of this where you're finding 2, cosine of 2, that's an identity, 2 theta. The cosine of 2 theta is cosine squared theta minus sine squared theta. Honestly, there's 2 more, but that's the one I use all the time. So what you want to do up here again is this is just telling you what quadrant to be in. This is in quadrant, looks like 4. Draw your triangle, put your theta. Tan is opposite over adjacent, so we're going to put 4, actually you're going to put negative 4 over adjacent 3, and the hypotenuse will be 5. And now I'm just going to write, what's the cosine of theta? Well, if I was standing here, cosine would be adjacent over hypotenuse, so that would be 3/5, and I'm going to square it. Sine would be opposite over hypotenuse, which is negative 4/5 squared. And then I'm going to let my calculator do the rest here. That's 9/25 minus, this becomes 16/25. And your answer is negative 7/25. Ooh, verifying identities. I mean, you really should have a note card of just these identities. So let's go over some of these. What your job is to do is really to get one side to look like the other side. So it's up to you how you do this, but I would say, okay, secant squared is, just this right here, is equivalent to 1 over cosine squared. And then cotangent x, cotangent is cosine x over sine x. And tan is sine over cosine. Well, if I'm multiplying all of these together, I can cross off some stuff. And so I'm left with 1 over cosine squared equaling this side, tan squared x plus 1. But you know what? What I could have done? I could have realized that this is actually just secant squared. And if I crossed off this and this one, and I have this left over, which is secant squared, that's done. That's good enough work for me. All right. Let's try this last page, and I'll be done. Let's do this again. Tan squared times cosecant squared. Tan squared is sine over cosine, so sine squared over cosine squared. Cosecant is 1 over sine squared. Cross that off. You get 1 over cosine squared. Well, that's secant squared, and secant squared is equal to 1 plus tan squared. So that's done. This one, secant squared, I would always try to change it to sines and cosines first. So secant squared is 1 over cosine squared. Tan is sine over cosine. Keep, change, flip. So keep, change to times, flip. This one would cancel with this, and you would have 1 over cosine x sine x. All right, well, I'm going to have to work on now this side. So cotangent, again, is cosine over sine over cosine squared. I'm going to do keep, change, flip again. Cosine x sine x times, change, flip, 1 over cosine squared. That cancels with that, and it looks like I'm going to have the same thing again, sine x, cosine x, which really those are the same. All right, and last one, a little bit harder but not too difficult. Cotangent is cosine over sine. Since I'm adding 1 and I have a denominator of sine, I'm just going to call it sine over sine, because sine divided by sine is 1. Well, I can make that one fraction right here on the top. I can actually call that, again, like this was a 4 and this was a 4, you would just add the top. So I would just call it cosine x plus sine x over sine x. Now on the bottom, you have a cosecant, which is 1 over sine. Well, if I do my same change flip, I would flip this to be sine over 1. And then these two are going to cancel, and look what I have left, cosine x plus sine x. All right, that's part 2.